Any questions? Without managing to solve the problem, anyone got a solution? Now, or did anyone manage to solve at least up to the angle? And we give you guys 2 more minutes and we'll look at the solution. All right, let's have a look at the solution. Was anyone able to solve the problem before we move on?
No, sir, I wasn't.
Okay. I'm sure that you guys made some headway though. Let's have a look at the solution. All right, so firstly we calculate the centroid distance. So we can calculate x bar and y bar. Remember, we're looking at the centroid, not of the the flat bar, but the centroid of the weld. So if we look at the shape of the weld, all right, look at that shape of the weld. That we're trying to find the centroid of that shape. And that's the case for all of these problems. We look for the centroid of the weld, not the centroid of the actual shape of the material. So weld that we're looking for. So for y bar, so we find x bar is 12.5, y bar is 50. Then using table 9-1 for torsional problems, we can find the polar moment of inertia. You guys understand what the difference between I and J is? I being the second moment of area and J being the polar moment of area. Does anyone know the difference? Okay, so I is a resistance to deflection, and that would be in a translational mode, where J is the resistance to deflection and rotation. When we try to rotate something, we try to twist it. J is the resistance to the twisting. Okay, where I would be the resistance to bending. If you can imagine a ruler in your hand and you bend it, that would be I the resistance to that bending. The J, if you try to twist your ruler, J is the resistance to that twisting. That's what the polar moment. Get to get polar moments and polar coordinates, because when we use polar coordinates, we're normally talking about circular motion. All right. So that's just a little add-on that you actually learn more in strength of materials. All right, so we calculate J, and we can calculate R, remember, which is the distance from the centroid to the furthest stress point of the weld. And we can calculate the angle, theta, which is the angle at which the secondary shear stress acts. We get that 36.869 degrees. We then, I will record this also once the power's back, and then I will also draw a little sketch of this, the shear stress, the secondary and primary shear stress, and go into a bit more detail. All right, then we have so we calculate the unit polar moment inertia, and then we can plug in the equation for the second polar moment. We solve. And remember, these are in terms of H. So we are solving the area, the polar moment, the secondary shear, the primary shear, and the components of the primary the secondary shear in terms of H, because we're trying to find H. So we find all of those in terms of H, and then we plug it into our maximum shear stress equation. So we have a maximum shear stress there, and we make H a subject of the formula, and we can solve. All right, so that's how we go about solving for the thickness H. Once we plug in just want to see here quickly. Just give me a moment. Let's do something quick. Yeah, this, I just realized there I've got H equals tau max over tau allowable, which isn't correct because tau max is tau allowable. That's what we're looking for. So when we're solving that equation, tau max equals the square root of tau x double prime squared plus tau y prime plus tau y double prime squared, we're going to get an answer with h as a variable. So there's going to be some coefficient, which is just your number with h, and that's going to equal your tau allowable, which is tau max, and then you will then solve for h. So then h will be, so from that tau max equation, tau max is tau allowable, and then you will make h the subject of the formula and solve for it. But yeah, writing it as h equals tau max over tau allowable, sorry, that's not correct. It should be h equals tau max, which is tau allowable, divided by the coefficient, whatever is, when you solve that square root equation, it's going to have something h. So then you'll divide that something, that numerical value, it's there. It's going to be 2h half. So if you look at tau max equation, it's equal then to 2h5520769 multiplied by 1 over h over h. So looking at that, if we then make h the subject of the formula, we're going to have 2h55207.69 divided by tau allowable, well, yeah, tau allowable or tau max, same thing. It's going to be then that 140 times 10 to the 6, and that will give you then your answer. Not sure if you're still following me there.
Sorry.
Sorry. It's gone very soft. I can hear you. Can you repeat your question? Can't hear you. It's way too soft. You need to increase your volume. A bit better. I can't hear you. It's too muffled and soft. You need to make your line a bit better. Yeah. No, I can't hear you. Sorry. I don't know if someone else knows what he's trying to say.
I've got no idea, but maybe you can just type it in the chat.
Yeah. Any other questions? Any other questions? You guys follow what I've explained here?
Yes, sir.
All right. Okay. So, like I said, that h is going to equal tau max divided by that 2855207.69. So you've just taken that tau max equation, make it h the subject of the formula, and you solve the Wild thickness. All right. But I will do a recording to go through this problem again. Right, the next question I want you guys to have a look at is this question here. So the problem states The permissible shear stress for the weldment illustrated 140 MPa. Estimate the torsion T that will cause the stress in the weld throat. Estimate the torsion, so you need to estimate T, torsion of the torsion that's applied, the torque. And once again, this is a torsional problem because you have twisting. That tube is twisting about the centroid. It's not bending, twisting. All right. I'm going to give you guys some time to solve this problem. This is actually a very easy problem. So if you aren't able to solve it, once you see the solution, you'll realize how simple it is. It's quite a simple problem to solve. I'll give you guys a few minutes to attempt it. If you have any questions, please feel free to ask. any solution yet or any questions? Anyone solve the problem yet? Okay, one thing you need to realize with this problem is that your primary shear stress is 0. There is no primary shear stress. If we look at the question, remember yesterday I was explaining to you with the counterleaf beam, with the force at the end, we had 2 modes occurring there, translation and rotation. If we look at this problem, we take this problem into space, we detach it, we shift the tube, but we apply torsion. What happens? Does it translate, or does it translate and rotate, or does it just rotate? Anyone?
What's your question, sir?
Or if you're listening, you heard the question. The question is, does the tube translate, rotate? So I say, does it only translate, does it only rotate, or does it translate and rotate? When applying the torque.
I think it's going to translate and rotate.
Anyone else? Anyone else brave enough to give an opinion? Come on, guys, no one can even see you. So just unmute yourself and say what you think. This is the best way to actually learn, if you get involved in the discussion.
So doesn't it just rotate due to there's nothing, it's not moving in a specific axis on the Y or X axis. Like it's just going in one circle around, quote unquote, the Z axis, if I could say.
Yeah, if we look at, imagine a tire. So your car is sitting off the ground. And all you do is apply a torque. It's only going to turn the tire. It's not going to want to push the tire down or to the right. You have no translational force, what they call it transverse force. Okay? There's no force acting directly down or directly to the side. So if this thing's in space, all it's going to do is rotate. There's going to be no translation. Which means if there's no translation, my primary shear, remember the primary shear force is caused by translational motion. A force that wants to move it in let's say in the X or Y direction. There's no force that wants to move it in the X or Y direction. So the weld does not experience a primary shear. It only experiences a secondary shear because there's only a rotation due to the torque. All right, so the primary shear stress is 0. And we'll only have a secondary shear stress. Now I'm going to give you a few more minutes to play around with that, and then we'll look at the solution. Anyone manage to solve it now? Okay, I'm going to give you guys 2 or 3 more minutes, and then we'll look at the solution. All right, let's look at the solution. So it's a very simple solution, very easy problem. We solve, this we go to table 9, 9-1. We look at a weldment. Here we have 4 weldments. So it makes a square. So the weld looks like a square shape because the symbol shows that we have a fillet weld all the way around. Okay. So we go to the table 9-1 and we then use the equations given to find polar moment of inertia. We find R. So R is equal to R sits in the center of the tube. So because it's not square, it's rectangular, we can just find, or either square or rectangle, we just find the center using X bar, Y bar. All right. From there, we can then find the second moment. Sorry, to find the secondary shear stress equal to MR over J, and M is T. Okay. A moment or a torque. Normally, we use moments when we look at bending. So this equation can be applied to both. If we use looking at bending or torsion. For torsion, instead of saying M, we can say T, because it's a torsion. That's the difference between the bending, a moment and a torque. A moment is for bending, where a torque is for torsion. All right. So we find the secondary shear stress. There should be, sorry, just give me a moment. We're going to have, we're looking for M. So we have R, we plug R and we plug J in. And so we get kilonewton per meter. So I'm just looking at the solution here quickly. If we divide R, basically we just need to plug in our the allowable, this tau double prime will become the allowable shear stress, which is given here as 140 MPa. We can plug in 140, the tau double prime will equal 140, will equal those, I think those units on the side, I'm just double check, it's going to be, well, we don't need to include that. I don't know why the K, the M is there, you can just scrap that. But in any case, we're actually more interested here at this point, not that. Not right. So then we make M the subject of the formula. M is equal to T, or T is equal to M. So once we plug everything in there, we get 4.289 kilonewton meters. All right. And that is the torque. So it's 4,289 Newton meters. Any questions? Any questions? All right, guys, if there are no questions, then we are finished the class. I just wanted to go through those 2 problems. And then we will continue in the next class with more complex. I just want to check our calendar quickly. Just give me a moment. Okay. All right. This Friday's class will be left for one to problem solving on this Friday. Next week we'll have a full week. So next week, Monday, Tuesday, and Friday, we'll have problem solving. Okay. But this week, Friday, I'm going to leave it for catching up. So you guys should be working through chapter 9 on Brightspace. So this Friday, I'm going to leave it for you guys to do catching up. Also, I will be on the class. So I will be logged in. If you guys have any questions, comments, or you want help with something specific, maybe you want help with the design project, you want help with some technology question you didn't understand, or any of the work, I'll be available that day during this, so on the 11th, on Friday. All right, so if you don't want to join, then that's fine. But next week we'll have a full week of classes, then we will have a week of holiday. Then when you come back on the Monday of the 28th, we have our semester test. Okay, so we have basically 3 more classes next week, and then the semester test will be, so you have a nice week holiday which you can study for the test, and as soon as you come back, we'll write. Okay, I see a hand up, Devin.
Just a quick question, sir. From when to when is the holiday you said, or the time away?
The TC holiday shows from the 21st to the 25th of March.
Perfect, thank you.
And that's according to the academic core calendar. If you go download it on TC website. So it shows the holiday from 21st to 25th. So obviously you won't have any classes. You guys can work on your design guide, you can work on the other assignments that you have for the classes, and you're studying for that semester test. Now remember, that semester test is just going to be based on chapter 8 and 9. Okay, probably just be maybe it can be 3 or 4 questions. I might pick 2 problems from chapter 8, 2 problems from chapter 9. It depends. It might only be 2 questions. It just depends on how I still need to set it up. So I'll still have a look. And we only have an hour and a half. So I need to give you enough time to solve the problem. All right. Any other questions? Okay. Then bye for now. I will end the class now, and please just go through those problems again that we've done today. Make sure you understand them, and then I'll upload the solutions later when I do the recording.
Perfect. Thank you so much. Okay, bye.
Rest of the day.